This is a statistical review of the scholarly article Planning, Teaching, and Assessing Elementary Education Interdisciplinary Curriculum, written by Cynthia Campbell and Mary Beth Henning out of Northern Illinois University. During the literature review, studies show students in schools which use interdisciplinary or integrated approaches perform as well as or better than students in schools which use non-interdisciplinary approaches. But to what extent does integrating university coursework and deliberate modeling of interdisciplinary instruction have on pre-service teachers' ability to acquire the knowledge and skills needed to effectively design, implement, and evaluate interdisciplinary curriculum? The rationale our researchers use is that they are university professors who teach social studies as an integrated approach to studying history, geography, government, culture, and economics. They were interested in examining the pedagogical beliefs, if there are any, of integrating the coursework. Researchers had three questions of interest. The first question is they wondered whether pre-service teacher skills in designing and assessing interdisciplinary content would be better if their social studies and assessment methods coursework were integrated rather than taught in isolation. Their second question is they were curious about what difference, if any, pre-service teacher, if any pre-service participation in integrated versus non-integrated methods coursework would have on kindergarten through grade 8 students' self-estimates of their perceived understanding about interdisciplinary topics. Question our researchers were interested in is they wondered if there would be a difference in pre-service teacher skill using assessment results to think reflectively about the quality of curriculum and assessment, instructional effectiveness, and student learning. During the literature review, the concept of interdisciplinary curriculum is introduced. Lyons in 1992 proposes viewing interdisciplinary as a stream that flows through a wide terrain of disciplines with its tributaries and currents forming a greater whole. Fogarty in 91 used the metaphor of binoculars as focusing the study of two disciplines overlapping content and skills. For the purposes of this study, interdisciplinary curriculum is defined as the shared planning and teaching of two disciplines to illuminate overlapping skills and concepts. The methodology of the study is where pre-service teachers experienced either integrated or non-integrated course instruction. Pre-service teachers attended their methods course once a week. There were 59 undergraduate pre-service teachers majoring in elementary education participating in the study. 33 of those students were enrolled in integrated course instruction, while 26% were enrolled in non-integrated course instruction. 180 elementary and middle school students participated in the study. The researchers state the number of males and females in the study were approximately equal. A detailed scoring rubric was designed with the intention to ensure inter-rater reliability and valid inferences. Both professors evaluated and scored the interdisciplinary units. Pre-service teachers interviewed 3 students following a structured format, and those students were identified by their classroom teachers as being average, above average, and below average in achievement. Notice that these classifications are in quotation marks because they come directly from the article itself, and that leaves for a vague definition of what defines each one of these terms. Mentioned limitations include the inability to measure students' direct learning across units based on assessment results and students' self-reflection for 2 given reasons. When you look at the statistical analysis of the article, there were 3 independent samples t-tests performed. The first was comparing the percentage points earned on interdisciplinary units by pre-service teachers whose social studies and assessment methods courses were integrated versus peer pre-service teachers whose courses were not integrated. The second independent sample t-test compared estimates by students whose pre-service teacher received integrated instruction compared to estimates by students whose pre-service teachers received traditional instruction. And the third t-test compared the percentage points earned on reflective essays between integrated and non-integrated instruction groups. There was also qualitative data from interview results used to document the students' learning. Why do they use an independent t-test? Well, independent t-tests are used to make a comparison between two groups or two treatment conditions. The mean difference between the two are being evaluated. Hypothesis tests using independent measures t-statistics. You state the hypothesis and select the alpha level. And as you can tell, our null hypothesis is stated here, and we have an alternative hypothesis stated here. We also select the alpha level as being at 0.05, which according to what I've learned in this course, is a relatively good alpha level to set. The researcher used independent t-tests since two different groups were being researched, and we did assume that the value of alpha was 0.05. When you look at the statistical results that are listed in the article, Test 1 compared the results from pre-service teachers with integrated instruction against pre-service teachers without integrated instruction. The p-value had a p-value of less than 0.01, which is less than our alpha of 0.05, which indicates those receiving integrated instruction performed better than those who did not. Therefore, we reject the null hypothesis. Test 2 compared the results from students taught by pre-service teachers who received integrated instruction versus students taught by pre-service teachers who did not receive integrated instruction. The p-value of this has a p-value of greater than 0.05, which indicates there was not a significant difference between the groups. Test 3 compared the results between the percentage points earned on reflective essays by pre-service teachers with integrated instruction versus percentage points earned on reflective essays by pre-service teachers without integrated instruction. The p-value of p is less than 0.05 indicates teachers who received integrated instruction had a better understanding of how to use assessment results to design instruction. Data included in this study included the number of pre-service teachers receiving integrated instruction, which was 33, the number of pre-service teachers not receiving integrated instruction, which was 26, and the number of students participating, which was 180. The only statistical data in the study were the p-values. The means and standard deviations for the groups were not included. Using the p-value, the authors indicate lessons designed by pre-service teachers receiving integrated instruction earned higher marks than those pre-service teachers who did not. These results could be biased based upon the instructor's evaluation. The statistics of the article supports the need for more research to be conducted to determine any potential benefits of interdisciplinary curriculum and instruction on pre-service teacher education in elementary school. A NASCAR crew chief is trying to determine how optimistic his team is compared to the previous year. He wants to determine whether this year's team has a different level of optimism than last year's team. A higher score indicates more optimism. Last year's team had a mean score of 15. A sample from 9 team members from this year's team was selected and tested. The scores for the team members were 7, 12, 11, 15, 7, 8, 15, 9, and 6. This year's member scores produce a sample mean of 10 with a sum of squares of 94. Step 1 of a hypothesis test is to state the hypothesis and select an alpha level. Our null hypothesis states that our mean is going to be equal to 15. Our alternative hypothesis states the mean will not be equal to 15. We are going to use an alpha level of 0.05. Step 2 is where we locate the critical region. We have a sample of 9 team members, and our T statistic, degrees of freedom, is n minus 1, which gives us a degrees of freedom equal to 8. With an alpha of 0.05 and degrees of freedom equal to 8, we look to our t-distribution table for a two-tailed test and an alpha of 0.05 and come up with critical t-values of a negative 2.306 and a positive 2.306. Step 3 is we want to compare the test statistic. To compute the t-statistic, you must first calculate the sample variance as a substitute for the unknown population value. Our sample variance, which is indicated by s squared, equals the sum of squares divided by n minus 1. Our sum of squares is 94. Our n minus 1 value is 8, which gives us 11.75. The estimated standard error, we substitute S2 in the formula for standard error, and it is calculated by the sample mean equal to the square root of the sample squared divided by n. Our values for our sample squared are 11.75. Our n value is 9, which gives us a result of 1.14. We're continuing step 3 of comparing the test statistic because we need to find out what our t-statistic is. Our t-statistic is the sample mean minus the population mean over the estimated standard of error. 10 minus 15 divided by 1.14 is equal to negative 5 over 1.14, which gives us a t-value of a negative 4.39. Step 4 tells us to make a decision about our hypothesis, or our null hypothesis, and state a conclusion. Our t-statistic we obtain is equal to a negative 4.39, which falls within the critical region. Therefore, we would reject the null hypothesis using the level of significance of 0.05. We can also conclude that there is a significant difference in the level of optimism between this year's crew members and last year's crew members.